DNA replication, clearly explained. So before the process of replication happens, first we need to unwind and unzip the DNA. So what happens is first, we have our 3D DNA strand. It unwinds and we get this 2D shape. And finally it unzips, leaving us with the leading strand and the lagging strand. So now let's go through the process step by step. Step 1. The DNA double helix is unwound using the enzyme helicase, forming a replication fork, which is basically what I just explained here. It unwinds and unzips using helicase, and it forms a replication fork, which I'll show you just now. Okay, so this is our replication fork. And the replication fork is basically just the part where the DNA is unzipped and where the DNA isn't unzipped meets. Now, the second step is a primer joins to the 3' end of a 3' to 5' leading strand. So, okay, so this is our 3' end. This is our 5' end, which means then this is our 3' end, and this is our 5' end because these strands are anti-parallel. Now, our primer comes along over here to the 3' end. Now, remember that this is our leading strand and this is our lagging strand, so first of all it comes onto the leading strand. Now the third step, the enzyme DNA polymerase adds free nucleotides to synthesize a complementary strand continuously. So what do we mean by this? Well, DNA polymerase comes along and it adds free nucleotides continuously to the leading strand. And of course, while this is happening, helicase is still unzipping the DNA molecule. So eventually, when the DNA strand is completely unzipped, you'll have two identical DNA strands. Okay, so basically what the primer is for, it basically just gives a starting point for DNA polymerase to begin the replication process, and DNA polymerase just adds on free nucleotides which have bases complementary to those of the leading strand. Now, for step 4, on the lagging strand, primers are added one by one into the replication fork as it opens wider. So what we mean by this is, over here at the basically all this will have already been replicated. So this has already been replicated in fragments. And what's going to happen here is we're going to add a primer. Now while helicase is unzipping the DNA molecule, we'll have, when it does unzip the molecule, we'll have enough room to add a fragment. And this fragment will go over here and match to complementary bases. And this is what we call a fragment. And what happens after this is that the fragments are joined together to form a complete complementary strand by another enzyme called DNA ligase. So DNA ligase just joins the two fragments together. Okay, so that's the process of replication. Now let's see what we need to say in order to get full marks in the exam. Here we will find that after replication has occurred, you'll have two identical strands just as a visual aid. And the marks you'll need for the exam, these are the 6 marks. First of all, DNA unwinds into 2 strands. primer is needed to start replication. DNA polymerase adds free nucleotides to the 3' end. DNA polymerase adds free nucleotides in one direction. One strand replicates continuously, the other in fragments, and fragments are joined by ligase.